everyone. My name is Nitya Narasimhan, and I'm a member of the AI advocacy team at Microsoft. Welcome to this lesson on understanding prompt engineering fundamentals. It's a part of the larger Generative AI for Beginners curriculum that takes you from fundamental concepts to functional application prototyping using generative AI. The main goal for this lesson is to help you build your intuition for creating better prompts by iteration and validation. Think of prompt engineering today as being more art than science. The only way you'll get better at it is through lots and lots of practice. So what are we covering today? Today, we'll talk about what prompt engineering is and why it matters. We'll look at how to construct prompts from simple content to complex instructions. We'll talk about best practices for improving the quality and relevance of your prompt responses. And we'll end with a quick look at a code challenge environment where you can apply these ideas in practice and explore these on your own. But before we dive in, let's recap what we know in terminology so far. We know that generative AI refers to a type of AI that generates new content using large language models. And we know that large language models are AI trained on massive data sets that are specialized to work with natural language tasks. So prompts are now the natural language or text inputs to an LLM that allow a user or an application to program its behavior and influence its response. So how does this relate to our target application and audience? Remember that we're building an education startup with AI apps that are focused on personalized learning. So let's think of what a prompt-based experience can look like for different users of our application. An administrator may want to ask the AI to analyze all the curriculum data and identify gaps in coverage. An educator may ask the AI to generate a lesson plan on the Civil War for an 8th grade audience. A student may ask the AI to teach me how to solve this calculus problem by giving me hints and examples that will help me learn. With that kind of context in mind, you should have a sense, an intuitive sense for what a prompt is and how our application users may construct these. So now let's talk about prompt engineering. What is prompt engineering and why should we care? To do that, let's kind of look under the hood and understand how prompts work. Remember that to the large language model, a prompt is just a sequence of tokens. The response or completion that it provides is just a prediction of the next token based on its pre-trained data. And most models have an associated token limit for their inputs. So one of the reasons prompt engineering matters is that you want to design your prompts to make effective use of those tokens to get quality responses. I recommend using tools like the OpenAI tokenizer to just, explore your own intuition for how the prompt design influences the number of tokens and also look at how those tokens are generated. Once a prompt is tokenized, we actually can think of base LLM behavior as simply predicting the next token, right? So in this example, I used the first line of a famous speech as my prompt and gave it no other instruction. I used the Azure OpenAI chat playground. The link is there and you should try it out yourself. Because the assistant was programmed to see prompts as requests for information, it returned a response that predicted what the most popular kind of information would be if someone had given that particular query as the text input. An instruction-tuned LLM refines this base behavior by kind of focusing on providing more detailed instructions that can help improve the quality of the response to match the expectations of your user or application. So for example, here we can see that the assistant is set up with a more detailed instruction as context in the system message of the OpenAI chat playground. And in this, the assistant is told that it needs to summarize content for a 2nd grade audience and keep the result to 3 to 5 bullet points. With this additional instruction context, entering the same prompt as before now gives us a much more relevant response for our application needs. So an educator who was looking to potentially use that data in a slide for that grade audience now has just a really quick copy paste and they have their slide ready. So based on this, how can we define prompt engineering? I like to think of it as the process of designing and optimizing your prompt till you get a response that meets your application or user expectations for quality and relevance. Just remember that this is a trial and error process where you have to iterate and validate the prompt until you get to a point where you're satisfied. It really is more art than science right now. So why should we care? Why is prompt engineering so critical for a generative AI application developer? We already know that prompts are how you're going to program your large language model. But there are a few factors that we can think about. First, these models are stochastic. That means there's an inherent randomness in the behavior, which can lead to you getting different results each time you use it with the same prompt. Models can also hallucinate. They really don't understand the input. They're literally just looking at prompts as a sequence of tokens and predicting the output based on some statistical knowledge. So it's absolutely possible that they predict an output pattern that looks valid, but is in fact not based in any factual knowledge. LLMs also have diverse capabilities. You have different models from different providers. The same model has different generations, maybe trained for different kinds of text outputs, different kinds of content outputs. So knowing the features and quirks is really helpful when you want to write a prompt. So you take advantage of the best things it offers and find ways to work around its limitations. So let's see some examples. We talked about the fact that models are stochastic. So look at these two responses. These two responses are responses for the exact same prompt on the exact same Azure OpenAI chat application with the exact same model, just taken a few minutes apart. And just that small variation has caused a fairly noticeable difference in the output because we didn't actually do any engineering of the prompt. We just put it out there. Think about how this would impact an application or user that was depending on that data to do something interesting. So here the responses have different lengths. They have different levels of detail. How does that impact that user experience? Let's talk about hallucination. So I deliberately picked a really older model, GPT 3.5, on the chat OpenAI playground. And I knew that had older data, so it was easy to try hallucinations there. And I asked it to generate a lesson plan for an event that doesn't exist. There is no Martian war, and even if there was, this is 2076, so that hasn't happened yet. So it must be fictional, right? But look at what the AI does. Do you see how the response actually meets our instructions, but has no indicator to tell me that the result is not factually correct? Now think about how this could impact a teacher who's going to use this in a lesson plan, but had no way of knowing or verifying that the information being given is actually rooted in real data. So that brings me to the third part, right? Model capabilities matter. So look at me now using the exact same prompt, but on a much newer model, GPT-4, that has more recent training data and also has been tuned to take advantage of the fact that it knows about hallucinations and will try to minimize their impact. Now see how the response still executes the task and creates that lesson plan, but it now provides an additional context that says, hey, this is a fictional event. So think now that how an educator could use this information in a more realistic way. They could either throw it away and say, well, I only want truth, or they can say, hey, this could be a great way to do a thought exercise with my students. So all we've talked about right now is what is prompt engineering? Why does it matter? Would it be nice to see the impact of prompt engineering in a real world application? You can look no further than GitHub Copilot, a generative AI application for a developer audience that was trained on the OpenAI Codex and was developed by GitHub in conjunction with OpenAI. It's really a model optimized for code generation. You can check the curriculum for a detailed set of links that walk you through the history of the project, where they talk about the various decisions and prompt engineering challenges they had to face. But I wanted to just show a really quick example of the application and how you as a user can engineer prompts to get the best value out of it. So this is an example provided by the GitHub developer advocates. So in this first example, they basically give a basic prompt. Hey, draw me an ice cream cone with ice cream using p5.js. And you can see that the image doesn't actually match your expectations, right? It looks more like a target. So how can we improve that? In the next step, the advocates basically went in and started refining the prompt. And if you watch how that was delivered, you can see that now that does in fact look like an ice cream cone. So what did they do differently? Well, they advocated 3 best practices for crafting prompts. Set the stage with a high-level goal. So here it starts off by saying, you need to draw me an ice cream cone with an ice cream scoop and a cherry on top. Then it sets simple, specific tasks. Nothing complicated. Draw a triangle with a point facing down. Then give examples. Ice cream cone should be a half circle on top of the cone. And if you actually go see the whole example, you'll basically see they specify the color, the textures, etc. And that's a great example of prompt engineering in practice. So we covered what prompt engineering is and why it matters. Now it's time to actually think about some basic concepts when you're designing your first prompt. So to reiterate, the simplest prompt is just content, right? You give it a sequence of words and it tries to predict the completion. There are no explicit instructions here. So in this particular example, this is the fundamental behavior of an LLM. I provided the first few words of the US national anthem, and you can see it immediately was able to complete it and predict the next few lines. So remember, this is the core behavior of an LLM, just prediction. It doesn't understand what the meaning of that prompt is. It just executes on completing it. In a more complex content example, the user is now asking questions again. There are no explicit instructions. They're not telling them what to do. They're just asking for information. But now the application has a system prompt that sets the context for the conversation. It basically defines the behavior. This is an example from OpenAI's examples category. Like there's a bunch of different templates, prompt templates and examples you can try out in their playground. And this is Marv, the sarcastic chatbot. Marv's system message says, hey, you're a chatbot that reluctantly answers questions with sarcastic responses. So it sets the context. And now when the user starts adding queries, you'll notice that we have a multi-turn conversation where every single message between the user and the assistant responding to it can be passed in to the application or model. And then it can kind of treat it as a sliding window where it's looking at the history of these tokens and trying to predict the next best response based on a conversation. And that's a fairly complex kind of prompt behavior. Now, the more popular use case these days is when there are explicit instructions given by the user themselves. So here, in a very, very simple case, a simple instruction, the user just has a text prompt that says, do this. Here they're saying, write me a description of the Civil War. Really simple, right? And it delivers. In a more complex version of this instruction prompt, the user provides more detail. Just like we saw with the GitHub Copilot case, they provide simple instructions and more details on what they're looking for. Now look at the difference between this and the previous example. See how the response is now structured to be more aligned to that user's need and how the content is more focused on the specific details asked. You're already seeing the response quality improve based on engineering that prompt. But wait, we can also instruct the AI to provide the response in a desired format. That's yet another interesting instruction we can give. So here we're saying, hey, could you return the output to me as a JSON file? Note how this is effectively engineering the starting prompt. We started with a very simple prompt, looked at the response, said, we could do better, and kept iterating on it till it gets to a point where, in this case, let's say an educator gets the result that they want in a format that they need. And you can see that it actually does return something that is JSON formatted. I've only put a snippet of the response, and if you run it yourself, you should see the whole thing. And of course, now that we know how a simple content prompt works and you know how instruction-led prompts work, you can start combining instructions with content. And this is actually a really interesting whole category of how you can engineer better prompts. Because when you provide primary content, you're effectively saying, I have an instruction, this is a task I want you to do. And this primary content is what I want you to see as the main source or like a more relevant source for the thing I want you to do. So it can refine its behavior to be more relevant to your specific context. Here, the prompt input has a paragraph as the primary content, and the instruction is asking you to summarize it in 2 sentences. Note now that the educator gets a summary the way they want it, it's 2 lines, and it gives them a response that they can trust more because they actually provided the source for the summarization. But we can take this